This is lesson 3-4, solving quadratic / linear systems. So I can solve systems of nonlinear equations in two variables with and without using technology. So that's the goal for today. I think when we talk about quadratics, we need to remember how to solve a quadratic equation first. And one of the ways you can solve a quadratic equation is to factor it into two binomials. And then we know that in order to get 0 as a solution, either x minus 7 is 0 or x plus 5 has to be 0, because the only way you can multiply two things together and get 0 is if either a or b here is 0. So that's what we do, is we factor and then set each factor equal to 0 to find the resulting answers, okay? So like on this one, we would take x minus 7, set it equal to 0, and the value for x would be 7. And here x plus 5 equals 0, so you'd subtract 5, and the answer would be negative 5, okay? So that's the zero product property. That's what we're going to use to do some of these problems, all right? So the factoring method. You can try this, can be tried on any quadratic, but most quadratics do not factor, and we'll get into some other methods. Like, I think you guys have probably done quadratic formula. We've talked about that in Algebra 1, so maybe remember that. That's another way to solve these. So the first thing you want to do is you just want to write all the equation in standard form, everything on one side of the equal sign. You always start with the x squared term first, the x term's in the middle, so this is called the quadratic term. This is called the linear term, and this is the constant. So you want to factor out a GCF, a greatest common factor, is what that means. So do all the coefficients have something, some number that divides evenly into them that you can factor out? If the equation only contains x squareds, you can factor it as a difference of squares. You could use the square root method. If it contains x squared and x, you're going to try and factor it into two binomials and then set each factor equal to 0 to solve, okay? So here's one where everything's already on one side, so we're going to try and factor to solve this. So if you remember, what you're trying to do is you're trying to come up with a pair of binomials, two termers here. These each have two terms in them that you would multiply together to give you this trinomial up here. So you're multiplying things to get x squared, which means you just have to take x times x to get x squared, right? And then to get 80, there's a bunch of stuff. 1 times 80, and there's 2 times 40, and then 3 doesn't go. 4 goes in there 20 times, and 5 goes in there 16 times, and 6 doesn't go in there, 7 doesn't, 8 goes in there 10 times. So all these choices multiply to give us 80, but only one of them, when we multiply the inside and outside pairs, will give us a positive 2 in the middle. And that happens to be the 8 and the 10. And if I make the 10 the positive and the 8 the negative, the middle pair would become 8x, negative 8x, and positive 10x. And those combine to give me that positive 2 in the middle, that middle term, right? So I know this is the correct factorization then. I don't need these things. That was just for me to check, make sure I was doing it correctly. And so I set each of these equal to 0. X would equal 8. X plus 10 equals 0, so x would be negative 10. So you guys try this next one here and see if you can do it. All right, hopefully you've put down 2 sets of parentheses on that. X and x go in each one of those, and for 15, I only got a few choices. It's either 15 and 1 or 5 and 3 if it's anything. Well, 5 and 3 work if I make them both negative. Negative 5 and negative 3, if I multiply those, give me positive 15. If I do the inside and the outside, I get negative 5x and negative 3x, and those do combine to give me negative 8 in the middle. So then I just take my two terms and set them equal to 0, and my solutions are positive 5 and positive 3. Okay? Remember those things? A little tougher. This is what the systems will look like when you set them up, because you're going to have a quadratic on one side and a linear on the other. So what do you need to do? Well, we need to get everything to one side of the equation to try and factor. So if you look, the minus x and minus x, they're just going to cancel out. So really, I can just, well, why don't we do this? I could add 9 to the other side like this and get 1. right? And then I could divide by 4, and I could get x squared equals 1/4. And I could take the square root, and square roots yield a positive and a negative. And what's the square root of 1/4? Well, the square root of 1 is 1, and the square root of 4 is 2, so it's positive and negative a half. The other way to do that problem is you've got 4x squared minus 9 equals negative 8, so you add 8 to get everything to one side, and that gives you minus 1 equals 0. And then that factors into 2x and 2x, 1 and 1, 1 plus and 1 minus. That's called a difference of perfect squares. Difference meaning the minus signs between them, and each one of these things is a perfect square. The square root of 4 is 2, the square root of x squared is x, the square root of 1 is 1. And then I set those equal to 0, and so this is going to give me positive 1/2. And this over here is going to give me a negative 1/2. And that's the same thing I got when I did it with the square root method. Okay? So it's another way. We'll look at all those things eventually in our work when we get up to chapter 5. Okay? So let's try this one over here and see how you do. So hopefully you got 5x squared. You're going to subtract 3x from 8x. It's negative 11x. You're going to subtract 10 from 12, and you're going to get 2. And now the factoring on this one looks a little different because there's a number in front of the x squared. So I got to consider that. I got to do 5x times 1x. I mean, that's the only way to get 5x squared. I mean, there's no other way to multiply and get 5 except 1 and 5 without using fractions or decimals, and we don't do those when we factor. And then for 2, it's just 2 and 1, but you're probably saying, well, 2 plus 1 doesn't make 11. Well, what you got to remember is when you do the outside pair, now you got a 5x times 2 is 10x, and 1 times x is 1x, and I need to make negative 11, so I'm going to make them both negative. And so negative 1 times negative 2 makes the positive 2, right? So we're good there. And these two combine to the middle, so we're good there. So my solutions are 5x minus 1 equals 0, x minus 2 equals 0. So here x is positive 2, and here x is 1/5. Well, it says solve by factoring, but I could do square root methods on this. I could just add 33 and get 36, and then take the square root of both and get positive negative 6. Or I can do x squared minus 33 equals 3. I can subtract 3 to get everything to one side, and I get negative 36. And I can factor that. This is a difference of squares again, so x times x gives me the x squared. 6 times 6 gives me the 36. If I make one positive, one negative, that makes negative 36. And the inside and outside pairs cancel out. So my solutions are still positive 6 and negative 6. Oh, here we go. Got a 6x on each side. They just cancel right out. Well, this is a difference of squares again. I can do x minus 7 and x plus 7. X is 7 or negative 7, right? All right. Solve by factoring. Well, here we've got a GCF. I mean, they both have x in common. So pull out the x, and you get 3x minus 5. And then you set these equal to 0. X equals 0 or 3x minus 5 equals 0. So 3x equals 5 and x equals 5/3. Two answers there. Same thing here. This one's got an x in common, so it's x plus 1. So x equals 0, x plus 1 equals 0, so x is negative 1. So this is just all review of factoring, so we know how to tackle the problems when we get to them here, all right? So here we go, quadratic versus and linear systems. So what you want to do is solve each equation for y and then set those two, the right sides then equal to each other. So then you're going to move all the terms to one side of the equation, setting it equal to 0, try and factor, use QF to solve, okay? Plug the x value back into either original equation to find the y. And then the solutions are ordered pairs, just like they are with systems, right? Linear systems, anyway. So, first step is to get y by itself. We get y equals in both equations. That equation up there is done. In this equation, I just need to swap a few things around. Like the y needs to come to this side. So if it's negative on that side, I just bounce over here and becomes positive. 2x stays where it is, and this 16 belongs over here with the 2x, so I'll just make that negative 16 over here. So if it jumps the equal sign, you switch the sign, right? So you add y to both sides, subtract 16, okay? All right, so then we've got these two both equal to y. So if these two are y, these two things have to equal each other. So negative x squared minus 4x minus 16 has to equal 2x minus 16. Well, immediately I see a minus 16 and a minus 16. Now let's take everything to one side of this equation here. So we got negative x squared minus 4x minus 2x equals 0. And I can combine those. Negative x squared minus 6x equals 0. And now factor out an x. And then you can set them each equal to 0. X equals 0. Negative x minus 6 equals 0. So you get negative x equals 6, and x is negative 6. Okay? All right, you guys give this one a try then. Pause the video, start it back up when you're done. So solving this second equation for y means I move the 3x to the other side and it becomes negative. So now set the right sides equal. You got negative 2x squared minus 29x minus 57 equals negative 3x plus 15. So nothing cancels there, does it? Add 3x to negative 29, that's negative 26x, and subtract 15 from 57. So those two actually we add, get negative 72. Is equals 0. All right. Hey, they all have a negative 2 in common. Let's pull that out first. That'll make things a little easier. It makes it a positive 13x and a positive 36. Phew, that thing was looking nasty earlier, but now this isn't bad at all. X and x, what can you multiply to get 36? Well, there's 1 times 36, and there's 2 times 18, and there's 3 times 12, and there's 4 times 9, and then 5 and 6 times 6. I like the 4 and 9. Positive 4, positive 9. Middle term is 4x and 9x make 13x. Set them equal to 0. This is just a scalar, just a multiplier. It's a scalar. It doesn't provide us any solution. Okay, so here the solution is negative 4. Here the solution is negative 9. Okay? You guys try this one and start the video back up when you're finished. So first step, I'm going to move my x to the other side. And then I'm going to set these two equal to each other. 2x squared minus 7x plus 7 equal negative x plus 5. Move everything to one side. Negative 7x plus an x is negative 6x. And minus 5 from 7 is 2. This doesn't look good at all. What am I going to do now? I can factor out of 2. But man, I can't factor that thing. That thing don't factor. So what are we going to do? QF. You knew it was coming, right? Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay? In case you didn't remember. Now I've told you. So let's go with this is A is 1, B is -3, C is 1. So we get opposite of B. It's the opposite of -3 is 3. Plus or minus the square root of B squared. -3 squared is going to be 9. Minus 4 times A times C over 2 times A, which is 1. So underneath here, I've got 9 minus 4 is 5. So this just becomes 3 plus or minus the square root of 5 over 2. Okay? Okay? So that's, looking back here, hang on one second. Group. Yeah, you know, it would have been nice if I finished these things up. Here I found the x values and didn't find the y's. Duh. So let's go back over here and find the corresponding y's. 2 times 0 minus 16, that's putting x equals 0 in, equals -16. So 0, -16 is one solution. And then do y equals 2 times -6 minus 16. -12 minus 16 is -28. So -6, -28 is our other solution then. Sorry about that. Same thing here. We're going to put in -4 first. So y equals -3 times -4 plus 15. So that's -12 plus 15, which is 3. So one solution is -4 and 3. The other solution is plugging in -9. And you get +27 plus 15 makes 3742. So -942. Man, we got to finish them up, don't we? Yeah, because I was looking at this one now, and I'm like, okay, I've got a positive and a negative 3 plus root 5 over 2 and 3 minus root 5 over 2. So what I need to do is I need to figure out what that is as a decimal. I'm just going to take the square root of 5, and I'm going to add 3, and I'm going to divide it by 2. So 1x is 2.62. And then if we take the square root of 5 again, and I make it negative and add 3, and then divide by 2, I get 0.38. Now let's substitute those back in over here. So we get y equals -2.62 plus 15. So really it's 15 minus 2.62. So that's 12.38. So one solution is 2.62, 12.38. And now let's put in -0.38 plus 15. And we get 14.62. There we go. All right, so 0.38 comma 14.62. Yeah, there we go. Okay, there's some problems for you to try in Delta Math.